All right, in this video, we'll actually go ahead and implement the dispatcher. So now, obviously, none of these tests will work until, of course, we implement both the on and the emit. And to save time, I'm going to implement them fully. But in a more traditional sense, you would write more tests and you would implement it incrementally as you add functionality. But since I already know what I want to do with this, we'll be able to talk about the code and write it sequentially, serially. So yeah, I'm going to go ahead and move this over so we're not looking at the tests. And for the dispatcher, we'll start off with our constructor. So what does the dispatcher need to be aware of? It needs to be aware of its handlers. So we'll say handlers equals object. It also needs two things that won't seem immediately obvious: an emit buffer, which is an array, and an in-emit, which is a boolean of false. The in-emit and emit buffer will be used in order to prevent redispatching actions if you're already in a dispatch method. So if you're already in a handler and you need to dispatch something, that dispatch that you're going to try to do inside of that handler will only be emitted after the handler you're currently in is finished. All right, so let's go ahead and do our on. Now, on takes two sort of things. It could take in a type or a callback, like you saw over here. It could take in a type as the first parameter and callback as the second, or it can take in an object. So what I'm going to do is on, I'm going to call the first parameter type or callback. Then I'm going to have callback equals null. Then I'm going to have status filter equals null. So what is status filter? We'll see what status filter is later, because status filter is going to be used to implement some of our helper functions. Then what I'm going to do is I'm going to say if underscore dot is object, type or callback, that means they passed in an object. So what I have to do is I have to then dissect the object and call on for every key in that object, for every individual thing. I need to dissect, turn this, extract all the properties and re-invoke on. So what I'm going to do is I'm going to say const unreg equals lodash.map. And the map is going to pass, I'm going to pass in type or callback as the thing we're mapping. And then for the map function, I'm going to have callback followed by type. And that's going to go into this dot on, passing in our type, our callback, and our status filter. Then I'm going to return a lambda, an anonymous function, that simply says unreg for each unsub goes into unsub and then invoke. So what's going on here is if it's a type, then we loop over all the enumerable properties of that class, or of that type, of that object. And actually, it should be type or callbacks. What am I thinking? So loop through all the properties of that object, and then re-invoke this dot on, but dissect the type and the callback out from the property and the value. But then map all of the returned functions that are used to unsubscribe into the unreg variable. Then I return a single function that then invokes every single one of those unsubscribe functions. So in this case, this dot on will still allow me to unsubscribe from all of these actions if I invoke the function returned by it. Then I'm going to say if not lodash.is function, callback. I'm just going to throw a new error. I don't know. Callback must be of type function. Something like that. Then I'm going to say const type equals type or callback, because I don't want to keep on typing type or callback all the time. Const handler, I'm going to do an object, and the object is going to have a status filter followed by a callback. So our handler that we're going to keep track of is going to keep track of the status filter as well as the callback that we should invoke. Then I'm going to check to see if we already have callbacks of this particular action type. So I'm going to say if not, this underscore handlers has own property type. Then I'm going to say this underscore handlers of type equals array of handler. Otherwise, this handlers of type dot push handler. So you can kind of see what I'm doing here. I'm saying if we don't have any handlers of that action type yet, go ahead and initialize a new array with only one item handler. But if we already do have items of that type, go ahead and push on that new handler to that array. Then all I have to do is simply return a function. And that function is going to go ahead and remove that handler from our handlers. So I'm going to say const handlers equals this handlers of type. Const index equals handlers index of handler. Remember, handler is the handler that we added because we're in that scope right there. If index equals -1, then return. Otherwise, handlers.splice at index 1. So all this will do is it will look in, it'll find the handler out of the handler's object, out of the array returned by the handler's object, and then remove it from that array. And that's it. That's on. Now, to do emit, I am going to write a helper function, and I'm going to write that helper function at the bottom of this file. And it's going to be function invoke handler, which is going to take an action followed by a deconstruction of status filter and callback. So basically, this invoke handler is going to take in an action that needs to be invoked as well as a handler object. Remember, our handler object, it has a status filter property and a callback property. Then I'm going to say, if we have a status filter and the status filter does not equal action.status, then return. Otherwise, callback passing in the action. So you can kind of see what's going on with my status filter. Status filter is what's going to allow us to write things like, instead of doing on, we could do .on request, which would only invoke that handler if the action submitted has a status of status request. We'll see examples of that later. So now that I have the invoke handler helper done, we can write our emit. So emit is going to take in one parameter called action. And the first thing we're going to do is I'm going to say, if we're already in an emit, then this .emit buffer push action. So if we're already in an action, if we're already dispatching something, then simply push on that action into a buffer that we'll be able to emit later and quickly exit out of the method. Then I'm going to say this emit buffer equals new array, this .inEmit equals true. Then I'm going to say, I'm going to do something interesting here, and I didn't write a test case for this yet, but there's going to be a special action called star, which will handle all actions. So what I'm going to do is say, if this handlers has own property star, so if someone subscribed to the star action, which will be just, handling everything, then say this underscore handlers of star, at star rather, for each H for handler goes into invoke handler, passing in our action, and then H as the handler. Then I'm going to say, if this handler, I'm going to do the same thing, but instead of doing has one property star, I'm going to do has one property action.type. So if we have handlers for this specific action, then do the same thing. Do underscore handlers at action.type, for each, H goes into invoke handler, action H. And that really should be enough to make some of our tests pass. As you see, we have two passes and 2 failures. But before we go ahead and fix that, let's write the code that will handle the emit buffer. So what I'm going to do is say const buffer equals this emit buffer. Then I'm going to say this emit buffer, I'm going to clear it out by setting it to an empty array. And then say this inEmit equals false. Then I'm going to say for let subaction of buffer, this .emit subaction. So it'll go out and it'll actually re-invoke the emit function so that there's never 2 action handlers executing at the same time. So it's pretty straightforward in that. So with this, let's go ahead and take a look at our tests and see what's failing and why. So I'll scroll through it later once I fix what's going on. So we're having an error on dispatcher allows object syntax for actions. So allows object syntax for actions. We expected 1 to be 2. And, oh, that's just because I have a bug in the test. You guys probably already caught that. Sorry about that. And that fixes everything but the on money. So that fixes everything but the observable action. So let's go ahead and do the observable action. So coming over into dispatcher, the observable action is really easy. So we're going to come down here to right underneath on. I'm going to say on money type, and simply going to return a new observable with a subscriber. And then I'm going to, inside of this observable, say this.on. Well, actually, I'm going to go ahead and I'm going to collect it. I'm going to say const unsubscribe or unsub equals this.on type, followed by a simply doing value goes into subscriber.next value. And then I'm going to return unsub. Actually, you know what? I can just combine this. I don't know why I put that out into its own variable. And so what this does is, if you haven't watched my Reactive Extensions course, I cover all things about observables and RxJS 5 and all that fun stuff. So definitely go ahead and check that out if you're a little rusty with observables. But this returns a new observable, and when it gets subscribed to, it'll go ahead and subscribe internally. When the observable gets subscribed to, then it'll subscribe to the dispatcher. But because we're returning the unsubscribed function, when the observable gets disconnected from, it'll automatically clean up the subscription. So that's pretty fantastic. So now if we hit Control S, we should get all green. So before I scroll through real fast, let's go ahead and put together my helper methods. So on, what I'm going to do is underneath on, I'm going to say on request type or callbacks, callback equals null. I'm going to say return this.on type or callbacks, callback a.status request. So what does this do? Well, if you invoke on request, it'll subscribe to that particular action, but it'll only subscribe to it if that action has a status of status request. I'm going to copy and paste this 2 more times, and I'm not surprisingly going to change one to on fail and one to on success. And then when you do that, be sure to change your action constants. So this will be status fail, and this will be status success. The last one I'm going to do isn't going to, well, actually, no, I'm not going to worry about that yet. So next up, I'm going to do the same thing, but for my observable. I'm going to say on request money type will return this on money type dot filter. Action goes into action status equals a dot status request. So this creates a new observable that's attached to that action, but then it'll filter out anything that's not a status request. And just like I did before, I'm going to copy and paste it twice. I'm going to do on fail and on success. And then I'm going to change the constants to this one's status fail and this one status success. Now I'm going to write 4 more helper functions on our dispatcher. And again, this all has to do with just a convenience methods that will clean up our code a lot. I'm going to scroll down to underneath emit, and I'm going to write request action. We'll do this.emit a.request action. Remember the a request function in our actions.js? All that does is it forces that action to have a status of request. Then, not surprisingly, I'm going to do fail. That takes in an action and an error. And this is simply going to say this.emit a.fail action error. Then I'm going to do succeed. I don't know why I have such issues with that word. This emit a.succeed action. Then we do one that's going to be interesting. It's not going to come up for a little while, but I'm just going to throw it in here anyway, just so we can get done with the dispatcher. I'm going to do respond. And respond is going to take an action and a validator. Now, a validator in this code base, once we start working with more of the model code, is going to be a basic class that can determine if if an operation failed or succeeded. So I'm going to say, if validator did fail, then this fail action followed by validator.message. So the validator will have a did fail property, which will be true if the operation was unsuccessful, and a message property, which will indicate what happened. Otherwise, this .success action. All right, so I'm going to go ahead and scroll to the top. Dispatcher is done. And it's the backbone of the majority of the client-side and server-side architecture. It's very, very important to understand. I know it might look a little weird. Some of the helper methods might not seem so useful right now, but they will come in handy very soon. And so I just wanted to get this all done in one chunk, really. So we have the dispatcher. He has a constructor. He initializes a bunch of properties. We have the on method, which just registers callbacks, basically. It can register it as a single thing, or it can register it as an object with properties for the callbacks. Then we have our helpers, on request, on fail, on succeed, or on success, which all do the same thing as on, but filter out the requests. Then we have on money. On money returns an observable sequence using this dispatcher. On request money, on fail money, on success money, which do just filter out the action based off of status. Then we have emit, just emits the action, and then request, fail, and succeed and respond, which are just wrappers around emit. And I'm not going to bother writing any more tests, but I would suggest testing, something like this, so easy to test that I recommend doing so. But I'm not going to spend any more time on the dispatcher because it's pretty much done, and we can continue on with the application. So with that, I guess we will see you guys in the next video.